Okay, so parabolas part 2. We had finished this page where we graphed one parabola, which was what we're accustomed to with x squared and y. And then we did one that was y squared and x. Our next chore, which we're starting now, is to convert from this form, put it here. The first thing to notice is which is my squared term. X is squared. So we're going to be using this one. We want to get it into that form. And the other thing to notice is we have a linear x term. So that means we're going to be doing completing the square over. Let's get the rest of this stuff out of here for a minute. I want to say that's equal to a plus 4y minus 29. And we're going to convert this into a perfect square trinomial so that we will have this form here, x minus something squared. Now what will that something be? I take half of this, which would be -3, I square it, I add that. The multiplier on here is 1, so what I have done is I've added 9 to this side, which means, that's right, I have to add 9 to this side. So now I've got x minus 3 equals 4y minus 20. Now notice that I have to have inside the parentheses y with a coefficient of a +1. Right now it's got a coefficient of 4, so that's not going to work. I'm okay on my left-hand side, that's looking good. But I have to factor a 4 out. And when I do, I'll have y minus 5 left. Now the form I want will reveal to me what my p is. I have to factor a 4 out of this, so I've got x minus 3 squared equals, when I factor a 4 out of 4, what's left? A 1. So that tells me that my p is equal to 1. And then y minus 5. My directrix is going to be going in this direction. My vertex is going to be hk, or let me write it down. Vertex is going to be 3, 5. So let's plot that right now. Over 3, up 5, 1, 2, 3, 4, 5. So there's my vertex. Oops, come on. There's my vertex. The distance from my vertex to my focus is p, which is a +1, so I'm going to go up 1. My directrix is in the opposite direction, the same distance, 1. So I've got an axis of symmetry going down through here. My parabola looks something like this. So did I find everything I needed to find? I got the vertex. Oh, I didn't identify the focus. What's the point where my focus is? 3 and 6, right? Let's go over 3 and up 1, 2, 3, 4, 5, 6. And my directrix, that's always going to be defined as a line. And in this case, it's going to be y equals, it's going to be 1 less, so y equals 4. Now I've handled everything I was asked to do. Put this one into standard form. In this case, I've got y squared, so I know I'm looking at this form here. How shall I do this? I know I want to have y squared being positive, so why don't I just leave the 8x and the minus 60 on this side. And over here I will add y squared to both sides. That'll give me a positive y squared. I will subtract 12y. And I know I'm going to have to get this into the form of a binomial squared. I take half of this, which is 6, and I square it. So I'm adding 36 to this side, so I have to add 36 over here as well. So I will have y minus 6 squared. And here I've got 8x minus 24. Let me swap these so I get it looking more like our model. And I'm going to factor out an 8. That's not enough though, is it? Because I need to know what my p is. I have to factor 4 out of there. Leaving me with a 2, that's my p. And because it's y that's squared, I know my directrix is going to be vertical. My vertex will be at 3, 6. My focus will, well, let me do my drawing first. I think that'll help us. We'll also find the directrix. Okay, so my vertex over 3, up 3, 4, 5, 6. So there's my vertex. My p is a positive 2, and it has to go this way, right? Perpendicular to the directrix. So there's my focus. Now I can say what my focus is. It's 5, 6. And my directrix is going to be x equals, and it's going to be 2 less. So here's my directrix, very sloppily drawn, sorry about that, which is 1. X equals 1. When I go to graph this, there it is. Let's see, did I find everything? The vertex, the focus, and the directrix, and then sketch the graph. Find the equation of a parabola that has the focus 1 minus 1 and a directrix x equals negative 3. X equals negative 3, so that's a vertical directrix, isn't it? So we know we're talking about this form here. Y minus k. We don't know what the vertex is yet, but I think we'll be able to figure that out in a minute. 4p x minus h. Let's think about this. If we've got why don't I sketch it? Wouldn't that make a little sense? Just a little sketch. So if I've got x equals -3 and my focus is at x equals 1, -1, then this distance from here to here, the change in x going from -3 to 1 is 4. And my vertex, I know, has to be right in the middle of that. So I think I know where my vertex is. This point right here obviously has to be -1 and -1. And my p is half of that, or 2. Let's see if that's right. So I've got y, and I know this has to be the k. So minus a -1 is +1. And 4 times 2 would give me 8. X, and here's my vertex, right? This is the one I'm interested in for finding my h. Also a +1. So there's my equation. Drawing the little sketch helps. We'll try this one. Here we have a focus at 2 and a vertex at 2. So the thing that's not changing, is my x. So that tells me that my axis of symmetry is going like this. So my directrix has to be going this way. I went back here because I realized I never sketched this, which might be useful to you to see it sketched. Oh, let's find my place. So the focus and the vertex are both on x equals 2. So that tells me there's my line of symmetry. My directrix is always perpendicular to that. So we're talking about this form here this time. Let me do a little sketch here. I don't actually know where the directrix is, but I do know that the vertex, let me say this is the vertex. It's at 2, 4. And my focus is going to be, let's see, 2, 0. So, and that's halfway between, that's 2, 0. Oh, this one's interesting because what I was assuming about the directrix and where it was going to be turns out to be false. It's not going to lie below. Let me label these, it'll help. Here's my focus. The parabola always wraps around the focus. Here's my vertex. The parabola always goes through the vertex, and it goes away from the directrix. So I know I'm looking at something similar to this. Well, this is a little bit surprising. The distance from my vertex to my focus is a value we call P, and in this case it's -4, isn't it? It's the first negative we've dealt with. Where will my directrix be? It'll be at y equals 8, won't it? Because it's another 4 units above. The focus was 4 units below. So if I know P, and I know the vertex, then I can write this equation. It's x minus the x-coordinate of the vertex squared. And over here for my linear term, I've got y minus the y-coordinate of the vertex. And this multiplier is my p-value, -4, times 4. So that's going to be -16. There's the equation of that parabola. Parabolas. Whenever A or C are 0, what is that telling us? It's telling us that we only have one squared term. So that's pretty easy to spot. We've been dealing with circles where you had 2 squared variables, ellipses with 2 squared variables, hyperbolas with 2 squared variables, and now for parabola, one of these is 0. This, of course, is where we started studying quadratics, was with only one squared variable. Remember this way of finding your axis of symmetry? Here's a little reminder on how you do that. When we look at the inverse of a quadratic function, this is a quadratic function, we recognize it. The inverse swaps all my y's for x's and x's for y's, and my axis of symmetry turns out to be horizontal for the inverse of a quadratic function. Well, here's a little summary for us. Here's how you define a parabola geometrically. Remember, using locus. It's a set of all points equidistant from a fixed point known to us as the focus and a fixed line known to us as the directrix. Whenever A or C are 0, the quadratic relation is a parabola. You can find your axis of symmetry using this little formula here. When the vertex is at the origin, everything gets so much simpler. It's just x squared equals 4py, and y squared equals 4px. So this is something we never paid attention to before because we were never measuring. We never even talked about the focus. Now we talk about the focus and we measure the distance from the vertex to the focus and we say that's P, and it is so important that we include it in our equation. Done in 20 minutes. Now you're ready to quiz on this.